Hi, welcome to L4M. In this video, we will talk about propositions which are in the form of conditional clauses. We will see a real-life example about conditional clauses. And lastly, we will see the table of truth values of conditional clauses. Some propositions in math are in the form of conditional clauses. The structure of a conditional clause is if P, then Q, where P and Q are two propositions. Since a proposition if P then Q consists of two propositions P and Q connected by if then, a conditional clause is a type of compound proposition. Some other types of compound propositions are P or Q, P and Q, P if and only if Q. When you see only one single proposition like P, Q, those are simple propositions. But when you see two or more propositions connected to each other, those are called compound propositions. Such type of propositions, compound propositions, are taught in discrete math in logic. But in our video here, we will just focus on conditional clauses. In a conditional clause, if P then Q, P is the given condition in my sentence, in my proposition, and Q is the consequent that follows P, in the case when the condition P is satisfied. So a conditional clause, if P then Q, can be also interpreted as if the condition P is satisfied, then the consequent Q will follow. We should be careful about something. If the statement if the condition P is satisfied, that means if P, then the consequent Q, then Q will follow, does not give us an exact information about whether the consequent Q will or will not follow if the condition P is not satisfied. This sentence only gives us the information that the consequent Q will follow if the condition P is satisfied. But what happens if the condition P is not satisfied? What can I say about the consequent? In this case, if the condition P is not satisfied, the consequent Q may still follow or it may not follow. Let's see an example. I have a proposition R in the it's a conditional clause. If it rains, then I will get my umbrella. Here in this sentence, I just say that I'll get my umbrella if it rains. I don't say anything about what I will do if it doesn't rain. So if it doesn't rain, I may still get my umbrella or I may not get my umbrella. None of these two cases contradicts to my sentence, to the meaning of this sentence. We need to understand only one case. According to my sentence, I know my proposition R. If it rains and I don't get my umbrella, then it will mean that I didn't do what I said in this sentence, right? I just didn't keep my word. Because I said that I would get my umbrella if it rained. So, if it rains and I don't get my umbrella, it means that I didn't do what I said. Let's make it more clear. If I split this sentence, if I say that this part, this proposition, it rains, is the proposition P, and this part of my sentence is this phrase is the proposition Q. So P is the proposition it rains, Q is the proposition I will get my umbrella. Then the proposition R will have the form if P then Q, right? In short. So this sentence, this proposition if P then Q has four cases: when P is true and Q is true, when P is true, Q is false, when P is false, Q is true, when P is false and Q is false. I will now check in the following pages. I will check each of these four cases one by one. Let's see the first case. P, it rains. Q, I'll get my umbrella. R, if P, then Q. If it rains, then I'll get my umbrella. So it's raining outside now. So Condition is satisfied, P is true. I got my umbrella, so Q is also true. So did I keep my word? Yes, I kept my word. So the truth value of my conditional clause should be true, right? So if P then Q is true, when P and Q are both true. Let's see now the second case. P is it rains. Q is the proposition that says I will get my umbrella. Now look at remember our proposition. If P then Q. If it rains, I'll get my umbrella. What's happening here? It's raining, so P is true. I'm not getting my umbrella, so Q is false. So you understand that this situation here, this scenario, means that I broke my word, because I said that I would get my umbrella if it rained. It's raining now, the condition is satisfied, but the consequent didn't follow that. So in this case, if P then Q, our proposition R is false. Okay. The third case, it's sunny outside, so it doesn't rain. It means that P is false. It's not raining outside, it's sunny. I'm getting my umbrella. I'm still getting my umbrella. So consequent followed. Q is true. I'll get my umbrella, and I got my umbrella. Q is true. So the scenario here, what I see in this scenario here, does it mean that I broke my word, which is if it rains, then I'll get my umbrella? No, obviously it doesn't break my word, because I said that I would get my umbrella if it rained. I didn't say that I wouldn't get my umbrella if it was not if it wouldn't rain or if it was sunny, right? That's why my proposition R, which means if P then Q, is still true. Let's see the fourth case. It's not raining outside, so P is false. I'm not getting my umbrella, so Q is also false. What about this scenario? Does it mean that I broke my word, which is if it rains, then I'll get my umbrella? No, obviously, this does not break my word, because I said that I would get my umbrella if it rained. It's not raining, so I think that I don't need to get it. I don't have to get it because it's not raining. The condition has not been satisfied. That's why consequent may not follow. So our proposition R, if P then Q, is still true here. Okay? So here is a quick summary of the truth values of a conditional clause. When the condition P is satisfied, if P then Q is true, if Q is true, but it will be false when the consequent Q didn't follow, when it's false. So in the case when condition is satisfied, if consequent Q follows, then if P then Q is true. If the consequent Q does not follow, then if P then Q is false. And this is the only case when R, which is if P then Q is false. In all other cases, you see if P then Q is true. You see, if the condition is not satisfied, the truth value of Q is not important. In any case, if P then Q is true. So when the condition P is not satisfied, if P then Q is true, regardless the truth value of the consequent Q. When the condition P is satisfied, the first two cases, if P then Q is true, when the consequent Q is true, otherwise it's false. Or I can summarize all this information in this sentence, in these two sentences maybe. A proposition in the form if P then Q is false only when P is true and Q is false. In all other cases, our proposition if P then Q is true. Okay? Thank you. Stay with us. Follow us. See you next video. Bye.